All right, so we're jumping into section 4.5. All right, so let me, I need to do this really quickly. I need to grab a picture. So let me put it up here. All right, so I want to talk about some of the properties of sines and cosines. I know that I grabbed some of the words, so we'll just fill that in as we go. So I have an unshifted sine function and an unshifted cosine function. So we want to talk about some of the characteristics of these graphs. So, and we've talked about this one before. The first one, where we'll complete this, the sine function is odd. What does that tell us about the sine function? What kind of symmetry does it have? Origin symmetry. So we're going to take advantage of that symmetry when we sketch our graphs of our sine function. Origin symmetry. We know that the period of the sine function, based on what we know about the unit circle, is 2 pi. And we see that on the graph by looking at the graph here. We're going uphill as we cross the x-axis. The next time we're going uphill crossing the x-axis is here at 2 pi. So the space between those 2 points where we're doing the exact same thing on the graph is 2 pi units. The domain. Well, when we introduced the concept of the unit circle, we talked about the idea of wrapping the number line around the unit circle, and we could just wrap it around and around and around. So we can plug any number we want into the sine function. So our domain is all real numbers. And I'll write it like that. The range. We can see it from the graph. We could also think about the unit circle. What's the smallest value of a sine of an angle or a number? -1 down here. And the biggest? +1. So our range is between -1 and 1. All right, so, and I'm going to include something that's important about both of them down here below. Cosine function is even. So what kind of symmetry does that imply? Yeah, we have y-axis symmetry. And we can see that if we reflected this over the y-axis, it would look exactly the same. For the sine function, if we rotated it about the origin, it would look the same. So we have y-axis symmetry. The period, just like for sine, we repeat on the unit circle every 2 pi units. And we see that on the graph. Here I'm up here at a maximum when x equals 0. And I go down, come back up to a maximum after 2 pi units. My period's 2 pi. The domain. Well, the cosine, if we think about the unit circle, the cosine of our number was just the y coordinate on the unit circle. We can have any, and we can figure out the y coordinate for any number after we wrap the cosine is the x coordinate. After we wrap the number line around the unit circle, we can figure out the x coordinate of any number. So our domain for the cosine function is going to be all real numbers. And our range. What's our range for cosine going to be? -1 to 1, just like sine. If we think of the unit circle, the biggest value is when our radius is 1. Our radius is 1, so the biggest possible value that the x coordinate could be is 1. Smallest value is -1 when we're over at the negative x-axis. The other important piece of information that we're going to use when we graph these things is the fact that I get a maximum or an x-intercept every quarter of a period. So if we think of the unit circle, we get a maximum or a 0 on one of the axes, and that's a quarter of the circle. So every quarter of a circle, we either get a maximum or a 0. So I'm going to say for both of these, we get key points every 1/4 period. And in this case, since our period is 2 pi, we get those key points every pi over 2 units. So we see on the graph, we get a 0 here. At pi over 2, we get a maximum. Another pi over 2, we get another 0. Another pi over 2, we get a minimum. And then we're back to 0 after another pi over 2. Same thing with the cosine. And by key points, I mean an x-intercept, or a 0, a max, or min. So those are our key points. So this, those happen every quarter of a period. So we're going to take advantage of that fact to help us sketch graphs. So we want to be able to, and one of the reasons that we want to be able to sketch graphs is that if we can visualize, if we have some way to visualize what this function looks like, it gives us more information about the function. We know how it's going to behave. We know more about it. So that's one of the reasons why we want to sketch functions. The main reason, though, is just it's fun to draw. You get to draw pictures in math class. Yeah. Back this way. Okay. So what we're going to talk about today is changing the amplitude and changing the period, and how we go about doing that. All right. So let's talk about amplitude. So for the amplitude, what we're interested in is functions that look like this. Y equals a sine x, or y equals a cosine x. So thinking just about transformations of functions, not necessarily trig functions, but transformations. What does it do when we multiply by a number out here in front of the function? What does that give us in terms of transforming functions? Bigger or smaller, which direction? Vertical, right? We get a vertical stretch or compression. Our y value here, we're multiplying here, our y value is changing, so that has to do with the vertical bit. So this multiplying out in front by a number gives us a vertical stretch or compression. We call the absolute value of A the amplitude. We want our amplitude to be positive. And the amplitude tells us how far up or down from the axis. I'm going to just say the axis. When we're not shifting our function, it's the x-axis, but otherwise it's going to be the axis that we go. That's our kind of our equilibrium position, or what our zero is. So amplitude is how far up and down from the axis the graph goes. So I'll give you, we'll do an example of sketching a sine graph where the amplitudes change. We'll do a couple on one set of axes. So let's sketch, and I'm going to do these in different colors. Y equals sine 2x. Why don't we do it? Yeah, that'll work. Y equals, 2 sine x. I jumped ahead. So here are my axes. What I do for these, or what I suggest you do, I'm going to say that the amplitude is 2, and we're not doing anything here with the x, so our period is 2 pi, and we get key points every pi over 2 units. So what I'm going to do is label my axes in terms of pi over 2 units. So pi over 2, pi, 3 pi over 2, 2 pi. Usually I will ask you to sketch 2 periods. On a quiz or a test, I would ask you to sketch 2 periods. So I'm going to go up and down 2 units. And sine of 0 is 0, so we're going to start here. And I'm going to sketch my maximums, my intercepts, and my minimums, my key points. And there's my graph. And to sketch another period, we could go forward this way, but I think it's a little easier just to go backwards, because we can take advantage of the symmetry that we know about. And I'm going to sketch my key points here every quarter of a period. And there's my graph. That would be okay as a sketch of that graph. And notice that the sine graph is smooth, nice and smooth and curvy. It doesn't look like a zigzag. So not looking for this. I'm going to erase that. And also notice that I've labeled my axes. I've labeled some points. So when the problem says sketch a graph, and you do something like this, that wouldn't be good enough. You need to have a little more detail than that. All right, let's put another graph on here. Let's graph y equals 0.5 sine x. So here my amplitude is, for this one, A is 0.5. So my graph would be a lot smaller. Something like that. And there would be 0.5 sine x. what would happen if I had something like this? We'll do this one in red. Y equals -3 sine x. It would flip over what? It would reflect over the x-axis. So the amplitude is 3, and it reflects over x-axis. So our amplitude is still positive, but that negative gives us a reflection. So I'll label, put a 3 here, and a -3. And instead of going up first, we would go down. And that graph would go all the way up. Oops. To there and down. And then we could go in the negative direction also. So let me get it in red. There we go. Doesn't look perfect here, but that's okay. It's a sketch of a graph. It doesn't have to be beautiful and perfect. And there would be sketches of 3 graphs with different amplitudes, and this one has a reflection. Whoops, I didn't go up quite high enough here, did I? Let me erase that. This one should go all the way up to 3. There we go. That looks a little better. Okay. All right, so we good there? All right, let's talk about the period change. Let's talk about changing the period. So for changing period, we're looking at a function that looks like this, a sine bx, or y equals a cosine bx. So if we think about just transforming functions, when we multiply by a number inside the function, what does that do to our graph? Yeah? It's a horizontal stretch or compression. And because sine and cosine are periodic, that stretch or compression changes the period. Well, let's figure out how. So I'm going to look at the sine function first. We can do a similar thing with cosine. So I'm going to say y equals a sine bx equals 0 when bx equals 0. The sine of 0 is 0. And then, so I'm going to say, so when x equals 0. I'm saying b is not 0. So when x equals 0, sine of a sine bx equals 0. And we're going to say y equals a sine bx equals 0 when this whole thing, bx, equals 2 pi. Well, this tells us if we solve for x equals 2 pi over b. So instead of the period being from 0 to 2 pi, we get the period being from 0 to 2 pi over b. So our new period is 2 pi over b. And we can do the same thing for the cosine. And we see that our new period, when we have a b value in there, is 2 pi over b. And we still get key points every quarter period. The period is just different. So let's look at an example of sketching a graph when we have a period change. So let's sketch y equals cosine 2x. So I'm going to say the amplitude is 1, b is 2. So our period is 2 pi over 2, which is pi. So we get key points at pi over 4 units every quarter of a period. So what I'm going to do then to sketch my graph is I'm going to label my axes in units of pi over 4. So pi over 4, one thing that will happen as we sketch these trig functions, we should get better at adding fractions. So pi over 4, I'm going to go 2 pi over 4, which is pi over 2, 3 pi over 4 pi. So that's going to give me 1 period there. And my amplitude is 1, so I'm going to go up 1 and down 1. And the cosine of 0 is 1, so we start here. And there would be 1 period of that cosine function. Make this point a little bigger so it goes through that point. There we go. And we can continue if we wanted 2 periods. I can go in the reverse direction. And I would just continue my graph over here. And there would be 2 periods of that cosine graph. And this goes through, there's that point a little bigger. All right, questions? Okay, I want to do one more example to show we don't always get our axes labeled in terms of pi. So I want to do an example where a period is not in terms of pi. Just so when we see an example like this or we see a problem like this, we don't worry about it. All right, we want to sketch this thing. So my amplitude is 3, b is 3 pi, so the period is 2 pi over 3 pi, which is 2/3. And we get key points every quarter of a unit. So a quarter of 2/3 is 2/12 or 1/6. So I'm going to label my graph, my axes, in terms of 1/6 units. So 1/6, 2/6, which is 1/3, 3/6, which is 1/2, 4/6, which is 2/3, and if I kept going, 5/6, 1. My amplitude is 3, so I'll go up 3 and down 3, make it a little bigger. And we're graphing sine, so sine of 0 is 0. And there we go. Whoops, got to go up to 3. What did I do here? Up there. Oh, this goes here. Let's get a point there, a point there. There we go. There, there, and there. There we go. There's one period. I know my labeling isn't entirely even. So there's a little more than one period. And if I wanted to go this way, I could just go in the negative direction. And there would be a little more than, well, there would be 2 periods. Got 2 periods going on. A little more than 2 periods. All right, questions there? Okay. Next time we'll talk about shifting our trig functions. And the reason that this list of problems looks a little odd is because I had to pick out the ones that just had to do with amplitude and period. And not all of these are graphing trig functions. Some are identifying things, some are finding the period, some are matching. So we don't have to sketch a graph for all of these.